real-time fashion. So I look forward to hearing this talk.
Hello, can you hear me? Cool. Okay, hello, my name is Hangwon Lee. I'm an assistant professor at Virginia Tech, and this is work done that I've done in Chroma Lab in University of Michigan before I graduated under supervision of Walter Osuki. The talk is about user study that we conducted to better understand real-time collaboration between a requester and crowd workers. So crowdsourcing works well for tasks that computers cannot automate and solve, leveraging human competition. So for example, this is a New Yorker caption contest. Each reader submits something, and they use crowdsourcing to pick up finalists and the winner. And they ask the readers to evaluate each submission and pick one of three options. So for us, it's easy to label whether each submission is funny or not funny or somewhat funny. But like this is something that computers, intelligent algorithm will not be able to do it easily. And so this is leveraging human computation, and then this kind of small task in crowdsourcing is called microtask. So microtasking is a well-established approach in crowdsourcing. It works very well for tasks that can be done in massively parallel fashion. It involves splitting a task into smaller ones that an individual crowd worker can complete without domain expertise and without knowing the context. However, not only requester needs to have an expertise in carrying out the method, but also requester needs to know the problem-solving process in advance to figure out how to decompose the task and aggregate responses. For example, for some tasks, especially when we want to create something, macrotasking does not work well. And this is because people often do not know what they want to do from the beginning until the end, and both the process and the goal can be open-ended. For example, imagine we have this painting and we want to create this painting in massively parallel fashion. What we can do is probably chop the painting into smaller regions, and maybe we have to write a detailed instruction for drawing a small portion of this painting, and it's going to be really challenging already. What makes even worse is that we don't have the painting yet, because if we had the drawing already, why would I create one? So yeah, so starting from scratch, the artifact that we want to create may change dynamically. So rather, what really happens in creative practice should be more of a continuous exploration of various ideas, iterating on the artifact in different fidelity. So we suggested that the requester collaborating with crowd workers in real time can be a solution to crowdsource open-ended task. In this setting, a requester and crowd worker create a digital artifact in real-time shared context, like Google Docs, for example, directly communicating to each other. And the benefit here is that the requester does not have to know what they want to do in advance and make the process exploratory and dynamic. And researchers have worked on these kind of systems, and one of such example is Apparition that we used for this study that Walter and co-authors presented at Chi 15. And this is a prototyping tool for graphic user interface. And requester draw and verbally describe what they want, and crowd workers behind the scene will listen to the description and replace the sketch with more refined elements. So in this case, they're creating some platform-based game like Super Mario. Another system that we created is Sketch Express, which is an extension of Apparition. In Sketch Express, crowd workers can demonstrate and remix animation for prototyping interactive behaviors. So within an hour, you can create a prototype that literally works, simply by describing what you want to workers. So we used Apparition to conduct the study. Let me explain how it works to better contextualize our motivation. So a requester simply speak and draw a rough sketch of a graphical user interface, or GUI, and then the crowd worker behind the scene will listen to the verbal description and see the sketch, and the workers will create a GUI prototype in real-time shared canvas. So let's say this is something that the requester drew on a canvas, and after tens of minutes maybe, workers will create a higher fidelity GUI prototype like this one. So this is a common structure that other similar systems have as well. Overall, most of the previous works in this domain have focused on creating the system and to see if it is feasible for workers to accomplish certain tasks. However, we realized that we have overlooked the other side, and we did not have a clear understanding on how requesters directly communicate and collaborate with workers. And we don't know the kinds of challenges that requesters encounter during real-time collaboration. Our goal of this study was to understand how requesters communicate and collaborate with workers. So we explored three different research questions. First, we wanted to know how requesters perceive and engage in real-time collaboration with workers. Also, we would like to understand the challenges that the requesters have when collaborating with workers. Lastly, in this kind of system, there is an asymmetry between requesters and workers in many different dimensions. For example, they use different GUI, they communicate in different modality, they have a difference in scale or expertise. So we wanted to learn how this various asymmetry in the structure would impact communication and collaboration. So we conducted a controlled in-lab study. We recruited 10 participants as requester. 5 of them were professional designer, and 5 of them were university students that had no design background. Also, we recruited 2 remote crowd workers from MTurk, and we asked the requester to create a GUI prototype of a to-do list application on a smartphone, which is something familiar to everyone. So this is the initial rough sketch that was given to requester. For analysis, we recorded video and audio during the session and transcribed it. Also, we conducted a post-interview to learn their perception. We coded each speech segment based on the level that we came up with. The additional task that we did was that we asked the requesters to draw and describe the sketch in a hypothetical asynchronous scenario, assuming there would be a designer who would work on this prototype. In this hypothetical scenario, there was no crowd workers, and there's no prototype that is being made, but simply recorded the requester's verbal description and sketch just for reference of comparison. So the paper presents 5 different findings that we learned from the study. For the sake of time, we'll present first 3 of them, and please read the paper for the more detail. Firstly, we found that real-time collaboration facilitated iterative design by immediate improvement on the artifact. Like based on the result of conversation coding, many of the speech segments were about giving feedback on the sketch, and the requester corrected the sketch more than 10 times on average per session, which does not happen in asynchronous setting, obviously. We looked into more details of corrective feedback and found that this is not entirely because workers did a poor job. Rather, as the requester can see the live progress of the sketch, they were able to make more detailed requests and iterated to refine the artifact in real time. For example, we found that the requests made in real-time collaboration are more explicit, more specific, and better contextualized compared to the ones that made in asynchronous task. And sometimes some requests are made on the fly. And I'll show you one example. So participant once said, Carrie, can you make this narrower? This is a mobile application, but the screen looks like a desktop web page, not mobile. So this is a good example where the requester was correcting the artifact and justified the request with more contextual information. So this indicates that crowd workers will get richer information and feedback on the outcome in real-time collaboration scenario compared to asynchronous one. Based on the follow-up interview, 7 out of 10 requesters preferred real-time scenario over asynchronous scenario. The primary benefit that they found was from the fact that they were able to give live criticism on the progress in real time. Second finding, we looked at how expertise influences the requester's language. We found that non-designers describe and designers declare. So let me unpack a little bit more. So all requesters had to explain this outer box of this application. So participants 3, a designer, said, so to start, I'm going to go ahead and draw the mobile device screen. In the meantime, P7, who is non-designer, they said, so I'm going to have like a box here, which is going to be an interface, like a rectangular box is height is bigger than the width. So other than the non-designer being somewhat verbose, you can see that P7 tried to describe the geometric property and the shape of the element. So in the meantime, designers simply declared the existence of element using a common design term like the mobile device screen. So we coded all the speech segment to see the difference, and I won't have time to give all the labels. Oops, what happened? I won't have time to define all the label, but like the main takeaway is that the non-designer tends to describe and non-designers tend to refer and locate the element using gesture or deictic terms in their language. So please refer the detail for the in the paper. So one potential interpretation of this is that the designer would have a clear connection between what they draw and what they speak about, while non-designer might have weaker connection than designers. From the crowd worker's standpoint, because they're also typically non-designer, they might have struggled to associate what they hear and then what they see on canvas. Similarly, terms and jargon that designer use could have been a challenge to non-expert crowd workers. Let me give you an example. So when they describe this drop-down menu, one non-designer requested like, I want to create like a drop-down menu in the upper right-hand corner with like 3 little lines. So you can see kind of a same pattern. They tend to describe it, depict it, and then give a geometrical property. On the other end, P1, a designer said, I want you to add a hamburger menu on top of right corner. So that's a so-called hamburger menu in designer's world, I guess. And I didn't even know what the hamburger menu was before this study, and probably it was the same for the most crowd workers. So if the designers start to use this kind of domain-specific terms and jargon, it would have been difficult for workers to quickly locate what the requester is talking about. Or they may even be misunderstand. In fact, in one of the sessions, this is what happened. So one crowd worker literally spelled out a hamburger on the canvas, hoping that this is a flyer for a restaurant. The designer quickly got frustrated and had to correct them, and which caused delay. So we also look at this term, specific term hamburger menu, across participants. 3 out of 5 designers used the term. 5 out of 8 designers, if we include all the people who participated in the pilot study, used the term hamburger menu. In the meantime, none of non-designers use the term because they simply don't know the term. And who knows, there could be a number of jargon that we do not know. Probably this could be a big challenge in communication if there is an expertise gap between a requester and crowd workers. The problem here is that because of the transient and instant nature of crowdsourcing, requesters do not have a chance to understand the expertise gap between groups as we would have in an in-person communication or collaboration. Lastly, last finding that I want to share is asymmetry in communication. So in operation, a requester can speak using real-time audio streaming, and workers can respond by typing in a chat box. So we thought this cross-modal communication was inevitable because there are multiple benefits of having asymmetry in communication. First is natural and multimodal. So the requester can draw, sketch while they're speaking. So if it was the typing, they have to go back and forth between drawing and typing. So it would have been difficult to refer certain element in the canvas. But it was easier if they say it and synchronize. The other reason why we didn't let crowd workers speak is because the requester's voice should be heard. And if all of them start to talk, and then because they just met for the first time, and then conversation could digress, then you don't really know who the requester is, and there could be a lot of problems. Also, we wanted to keep workers' environment private. So this is the natural choice for us when we designed the system, but it was not preferable by the requesters. So they said cross-modal communication was not preferable because it's simply awkward. They're just not familiar with it. And also, workers did not always acknowledge requests in the chat box because they asked us, made a request verbally, and then crowd workers tend to just start right away instead of saying okay or yes in the chat box. And the requester did not always monitor chat box because their primary modality is speech as opposed to typing, so they could always speak and then doesn't have to check out the chat box. Another problem was that mixed ephemerality. So speech is ephemeral and text isn't. So I can give you an example. So this is 9-minute long history of session P7. And as you can see, you can see nothing from the requester, Only chat messages that are left in the history is from workers. So immediately you can see worker was not able to recall all the requests that was made because species ephemeral. There's no record of it, and they cannot recover context by reading this history. So if you look at the history, it's just one side of the story, and then you cannot really tell what's going on. So if some crowd worker joined the session later, they cannot have a working memory out of this session. And also it's confusing. It's like if you see a 4 consecutive okay, it's hard to know whether it is okay from like 1 minute ago or 10 minutes ago. So yeah, based on the 5 findings that we discovered, we provided a 5 design recommendation in the paper, and which can inform future crowdsourcing system. And I want to have time to cover all this. Please refer the paper. To conclude, our vision, so we did a user study on the requesters side to investigate real-time communication and collaboration with workers, and findings and design recommendations will be useful for the future interactive system. Eventually, our vision is to make crowdsourcing an approachable method for end-user requester, especially in the creative context. Thank you very much, and I'll be happy to take any question, and I want to advertise that I'm highly recruiting PhD students.
We have time for 1 or 2 quick questions.
Hi, I'm Brandon from National University of Singapore. So I see that a lot of the tasks that requesters are asking, they could have just done it themselves and made it faster. So do you see maybe the point of this would be for much more open-ended, ill-defined description that the workers need to be sufficiently skilled?
Yeah.
Because it doesn't seem that you conducted it fairly this way.
So I see there are a lot of opportunity there. Like for example,